Changing analyzers should not break live search. OpenSearch aliases let you rebuild the index, test it, and flip without downtime. You'll learn how the pieces fit into a workflow that rebuilds an index, validates search, and switches the live alias safely. I'm Professor Pi, teaching search and IR with simple Python. Search systems must evolve. Maybe you want a sharper analyzer, different token rules, or a mapping tweak. But you can't take production search offline just to rebuild. Index aliases solve that. They let you point logical names at concrete index versions so you can build and validate a new index while traffic keeps flowing. Conceptually, an alias is a label that maps to a real index. Your app asks for read alias and write alias. Today, the concrete index might be KBV1, and tomorrow, KBV2. You build KBV2, run realistic queries against it, then flip the alias in one atomic step so users never notice a gap. That flow keeps reads and writes stable while you iterate on analysis or mappings. We'll build a tiny workflow. Check connectivity, create an aliased index, write documents through the right alias, build a candidate index with a different analyzer, test relevance, and then flip the alias atomically. It's the core safety pattern without production complexity. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To start, confirm the client can reach OpenSearch before making changes. This snippet connects Python to a local OpenSearch cluster and checks that requests can reach it. Before changing aliases or rebuilding indexes, you want one tiny health signal that the client is talking to the service you expect. The OpenSearch object is the shared client used in the rest of the tutorial, and client.ping gives a simple boolean instead of creating data yet. That keeps the first step safe and easy to repeat while you confirm the runtime path. The visible output shows whether OpenSearch is reachable before any index changes happen. Now that the client is talking to the cluster, create the first concrete index and point aliases at it so live code can use logical names. This example creates the first OpenSearch index version and hides its concrete name behind aliases. Live search code should not need to know whether the real index is KBV1 or a later rebuild, because read alias is what query traffic will use. Write alias gives indexing code a separate target, and isWrite index makes the write route explicit for this first version. The schema is intentionally small. Title and body are text fields, which is enough to show the cutover pattern without a long mapping. The output confirms OpenSearch accepted the index creation and shows which concrete version was created. With an aliased index in place, write a small set of documents through the logical write target so your app flow stays consistent. This code sends a small document set into OpenSearch through write alias instead of the concrete index name. That matters because the application can keep writing to the logical target while you later rebuild and move the alias. The bulk body uses the new line delimited action and source shape expected by client bulk, with one index action followed by one document. Refresh equals true makes the new documents visible to the next search step, which is useful for a tutorial or a small test run. On a high ingest system, frequent refreshes can add indexing overhead. The output shows how many bulk items OpenSearch processed and whether any item failed. Now, build a candidate index with an improved analyzer and load the same docs to validate relevance before any live switch. This snippet builds KBV2 in OpenSearch and tests it directly before any live alias moves. Analyzer changes can improve one query and hurt another, so the candidate index should be searchable while production traffic still uses read alias. The schema changes title and body to use the English analyzer. Then client bulk loads the same bulk body into the new index. The multi-match query checks a retrieval flavored phrase against title and body, with title prime 2 giving title matches more influence than body matches. The output shows the top candidate hit and hit count, giving you a quick relevance check before switching traffic. If the candidate looks good, perform one atomic alias update so the app keeps using the same logical names and never loses a target. This example switches OpenSearch traffic from KBV1 to KBV2 with one alias update request. A bad cutover often comes from removing an alias first, then adding it later, leaving a gap where live search has no stable target. The actions list removes read alias and write alias from IDX, then adds both aliases to IDX2, with write alias marked as the new write target. Client.indices update aliases applies those alias edits together, so the application keeps using the same logical names. The final search goes through read alias, and the output shows the live alias now returns the validated top document. In a real project, you would map these names to your deployment pipeline. You'd build KBV2 on a staging node, run a batch of representative queries, measure simple ranking numbers, and only then push the alias swap to production. That clear split build, test atomic switch is what prevents downtime or partial reads. Index aliasing, in short, it decouples logical targets from concrete indexes so you can rebuild safely. Use it when you need zero downtime index changes, analyzer experiments, or mapping migrations. Just remember, swaps are atomic, but your application must always use the aliases, not hard-coded index names. To extend this example, run the same flow with a labeled query set from your dataset. Measure NDCG before and after KBV2, and iterate on analyzer rules like stopwords and stemming until the metric improves. That concrete measurement ties each change back to real ranking behavior. If short, practical IR helps, subscribe and watch the IR videos.